Hello everyone, this is Ken from grade 11 News. On this video, we're going to answer the Conceptual Understanding Questionnaire, which is related to statistics and probability. Number 1. The 2010 Philippines census found the chance of a household being a certain size. The data is in the table. Household by age 2013. Draw a histogram of the probability distribution. The size of a household is 1, 2, 3, 4, 5, 6, 7 or more, and the probability is 0.02, 0.02, 0.06, 0.14, 0.16, 0.34, and 0.26. So this is our histogram of the probability distribution of the given table. Question: is it unusual for a household to have 6 people in the family? We must look at the probabilities in order to determine this. We cannot just look at the probability of 6 people. We need to look at the probabilities of X being 6 or more people, or the probability of X being 6 or less people. The P of X is greater than or equal to 6 is equal to P of X is equal to 1 plus P of X is equal to 2 plus P of X is equal to 3 plus P of X is equal to 4 plus P of X is equal to 5 plus P of X is equal to 6 and equal to 0.02 plus 0.02 plus 0.06 plus 0.14 plus 0.16 plus 0.34 and total of 0.74 or 74%. Since this probability is more than 5%, then 6 is not unusually low value. The P of X is less than or equal to 6 is equal to P of X is equal to 6 plus P of X is less than or equal to 7 is equal to 0.34 plus 0.26 in total of 0.6 or 60%. Since this probability is more than 5%, then 6 is not unusually high value. It is usual for a household to have 6 people in the family. Number 2. Look at the following figures below and find the area of the shaded region. Is method finding the shaded region in figure A and B the same? In figure A, the area of the shaded region in a rectangle can be found by using this formula. A is equal to length times weight. So A is equal to length times weight. So our length is 10 centimeter times 15 centimeter. So in total of the area of the shaded region is 150 centimeter. In figure B, the area under the normal curve can be found using the Z table. Number 3. You are applying for a job that requires a score on either a B test or an A test. The company needs only one test result. You have acquired scores on both tests. You've scored 98 on the P test and 112 on the A test. Which test result will you most likely to submit? Is the information enough for you to convince yourself on submitting your chosen test result? Knowing the scores of 2 tests cannot convince myself, since I didn't know the mean and standard deviation of 2 tests, so I cannot judge in which position to choose to submit. Number 4. Below are shown the histogram of the resulting frequency distribution, each based on 500 means. 4 scores were sampled from a uniform distribution 500 times and the mean computed each time fun n is equal to 4. The same process was followed with means of 7 score from for n is equal to 7 and 10 score for n is equal to 10. How will you describe the distribution as the value of the sample size n increases? When the sample size n increases, the distribution become more normal and the spread of the distribution will increases. In short, as n increases, the distribution gets closer to a normal distribution. Number 5. A certain population has a mean of 50 and standard deviation of 5. If random sample of 15 measurement is drawn from this population, how will you describe the sampling distribution of the sample means, assuming there is no limit to the population? First, we need to identify the given information. Mean is equal to 50 and standard deviation is equal to 5 and n is equal to 15. Second, determine the mean of the sampling distribution. So we have mean x is equal to mean and mean x is equal to mean is equal to 50. Third, we will solve the standard deviation of sampling distribution. Standard deviation x is equal to standard deviation over square root of n. Standard deviation is equal to 5 and square root of 15, and total of 1.29. Therefore, the sampling distribution has the mean of 50 and a standard deviation of 1.29. Since the standard deviation is large and very far from 0, sample mean is a poor estimated for the population mean. How do you estimate the population mean when the sample values are not that large enough for the central limit theorem to be used and normal curve concepts cannot be applied, or when the population standard deviation is not known? If the data are not normally distributed, we can estimate the population mean by sampling distribution of standard deviation. There are central limit theorem, z-table, and t-table to support on the information of the population mean. Then, the sample mean will be approximately normally distributed. This will hold true regardless of whether the source population is normally provided the sample size is sufficiently large. Explain the difference between the t-distribution and z-distribution. The difference between the t-distribution and z-distribution is that the t-distribution ideally used when n is greater than or less than 30 and standard deviation or the variance of the entire population is unknown, or that the only standard deviation given is from the sample, while the z-distribution or the normal distribution ideally used when n is less than or equal to 30 and standard deviation or the variance of the entire population is given. Both can be used for determining the confidence interval population mean and confidence interval of the difference between two means. The t-distribution has a graph that is bell-shaped and symmetrical about the mean. It is more variance since t-values depend on the function of the mean and standard deviation, while the z-distribution has a graph that is bell-shaped and symmetrical about the mean. Z values only depend on the fluctuation of the mean, from sample to sample. And that would be all. Thank you.